Okay. Good afternoon, everyone, and welcome to our subject, Principles of Steel Design. And for this afternoon, we will be discussing the last topic included in our midterm examination, or the last topic under the tension members, which is block shear rupture. So far, we already discussed two types of limit state, which are yung gross section yielding, or GSY, and then NSR, which is yung net section rupture natin. So we also have yung slenderness limitation. And for today, we will be discussing the fourth requirement, which is yung block shear rupture natin. Kasi as said by the code, when talking about the capacity of our section, hindi lang basta, hindi siya always nagko-control by tension yielding, tension rupture. Another phenomena na pwede mangyari is yung block shear rupture, or kailangan tingnan natin yung block shear strength ng mismong connection natin. So the failure of a member may occur along a path involving tension on one plane and shear on a perpendicular plane. So ang ibig sabihin, kung dati ang kinoconsider lang natin is yung about sa gross area, na sa net area, and then all of those consideration are based from tension na plane, okay, or perpendicular na plane. Ngayon, para masatisfy itong block shear rupture, kailangan meron tayong shear plane na tinatawag. Okay? So let's us look at with these three shapes na meron tayo. So we have an angle, a wide flange, and a tension member na naka-weld. Naka-weld siya sa isang plane. Okay? So when looking at, halimbawa, itong portion natin dito sa angle bar, as you can see, ito yung ating applied loading. So before, kapag halimbawa kinoconsider natin is gross section yielding, ang kinukuha natin is actually itong area na to, di ba? Yung area gross, okay? Yan yung base sa GSY natin. Yan yung kinoconsider natin. Baga yung perpendicular na area na cross-sectional area na nire-resist nung ating, nagre-resist sa loading natin. And then another condition, as yung tinatawag natin net section rupture, nadadaan siya dun sa butas natin. Okay? Kaya ito yung ating net section rupture. Okay? Then ang another consideration na dapat natin i-include is hindi lang lahat naka-perpendicular na area. We need to consider a phenomena na pwedeng mag-fail siya kasama ang shear plane, o an area parallel dun sa applied loading natin, which is yung shear plane natin. So dyan papasok si rupture, so yung block shear rupture natin. So nangyayari, ito yung ating shear plane, and then this is our tension plane, and then ito yung matitira dun sa section natin, o yan yung pwede mag-shear off dun sa section natin. So kaya kailangan natin siya i-consider kasi possible din mangyari yan dun sa tension member natin, dun sa lifespan niya. Okay? So when looking at halimbawa, a wide flange naman. So, alam natin si wide flange, meron siyang top and bottom flanges. And then, when you look at the connection at the top, makikita nyo, ganito yung mga pwedeng scenario sa kanya. Pwede siya magkameron ng, dun sa one side, pwede siya magkameron ng shear block o block shear dun sa one side. So, yung block shear on one end can also be the same block shear dun sa other end. So, kapag wide flange ang pinag-uusapan, pwedeng isa lang yung i-calculate mo and then just multiply it by 4 para i-consider lahat ng possible failure and total capacity na pwede i-provide ng connection natin when it comes to block shear failure. Okay? And then we also have dito sa kapag welded yung connection natin, we have an applied loading, and then yung welding natin, so halimbawa welded yung ating connection dito sa portion na yan. Okay? So again, pag sinabing shear plane, tatandaan natin pag shear, lagi pinag-uusapan natin is an area na parallel dun sa loading natin. So, ibig sabihin, ito yung loading natin. So, itong area na to, itong segment na to, which is parallel dun sa loading natin, same ng direction, ibig sabihin, yun yung shear plane natin. And kapag sinabi natin tension, tension siya, dapat yung ating area or cross-sectional area is naka-perpendicular doon sa loading natin. So this is our loading. So perpendicular area is this end. So yun yung kailangan. Para masatisfy si block shear, kailangan may combination siya ng shear at ng tension. Okay? Hindi siya pwedeng shear alone. It should be a combination of shear and tension. So, dyan papasok si block shear failure. Okay? So, yan po yung block shear failure natin. And ito yung itsura niya sa actual, ano? So, let's say we have a tension member at this one, and we specify itong point to, itong position na to. When we apply a loading dito sa end niya, ito daw yung possible na pwedeng failure niya. Mapapansin nyo, yung failure niya, gusto nyo mapunit nung kabuuan ng connection natin. Okay? So dito, makikita nyo, papansin nyo, nag-start ang failure is dito sa tensile failure natin. And then, papansin nyo, nagdire-diretso siya dito sa mismong shear plane dito. Okay? So, ibig sabihin, nagmamanifest siya ng block shear failure. Kung ang pinag-uusapan natin ay gross section yielding lang, ang failure lang na ang titingnan natin is itong portion na to. Okay? Failure na perpendicular doon sa section natin, that is gross section yielding. And kapag net section yielding naman tayo, ito naman yung mag-fail sa kanya. Dapat dito siya, mag-end-to-end siya ng buwan natin. Pero since yung actual failure na nangyari dito sa drawing na to, manifesting a direction na nag-shear siya, and then nagte-tension, and then nag-shear, that is what we call block shear failure. So, ito yung magiging matatanggal na portion sa atin once na nag-fail na siya. Ganun din yung condition when we have a welded connection. As you can see on this diagram, meron tayo dito welded connection, and as you can see at the bottom, may nagmamanifest na fracture dito. So once nag-start yung fracture doon, so possible na magtuloy-tuloy siya along its length, and then pupunta siya dito sa taas. Okay? Same way dito sa nasa ilalim. So we have a combination of shear and tension fracture. So once na nag-manifest na further dito, that is yun yung magiging failure niya. So matatanggal na siya ng kabuuan. So that is block shear failure. Okay? So let's look at a video showing kung paano nangyayari yung block shear failure. Ano? So for a while, itingnan natin yung manifestation ng block shear. Okay, so allow me to share this one. So, pa-verify kung makikita nila nag-play, ha? So, nag-play ba sa end nila? Okay. So, yan. Mapansin nyo, nag-fail yung natin. Again, replay ko lang. Again, pa-verify kung nag-play sa end nila yung video. Okay. Nakita ba? So, anong nangyari? Okay. Dito, ito yung section natin. We have an angle bar. Okay. As you can see, the failure starts dun sa dun sa loading natin dyan is pataas. Ano? So, yung failure na nag-start is sa tension. Papansin nyo, una na napupunit dito sa side na nasa edge, ayan, napupunit yung nasa taas. And then, nung napunit siya, kung net section failure tayo, dapat dediretso siya dun sa portion ng kabilang plate natin, dun sa other part ng plate natin. Pero since yung manifestation ng cracking natin, ng fracture natin is dumiretso pababa dito, ibig sabihin, mas nag-govern yung block shear failure sa kanya. And as you can see dito, pag inano natin, yan, napupunit na siya pababa. And eventually, may iwan o matatapyas na black portion dun sa steel material natin. That is block shear, ano? Okay, so allow me to share also another video showing yung block shear. Okay, let's look at the next video. So same angle bar tayo, pero dito itingnan niyo yung mga views, meron tayong elevation, side view, tsaka isometric view. Pansinin niyo yung lines. Yan. Habang pinupull sa taas ng tension, ayan, nag-elongate na paunti-unti yung line natin dito. Then tingnan niyo yung failure, kung ano nangyayari doon sa failure niya. Ayan. And tumataas na to, yan, napunit na siya ng horizontal o perpendicular doon sa loading. And then, nagtuloy-tuloy siya along o yung parallel doon sa loading natin o sa shear natin. So hanggat hindi na pupunta doon sa pinaka-edge, tuloy-tuloy sustain ang loading natin. Then eventually, yan, nag-fail na siya dyan. So once na napunit na ng buo yung mismong section natin, doon na nag-fail yung structure natin. So that is what we call block shear failure. Na kailangan i-consider natin doon sa calculation natin ng mga limit state natin kasi we need to compare that phenomenon doon sa gross section yielding natin and also doon sa net section rupture natin. Okay? So let's go back doon sa slide natin for a while. So pagbalik doon sa slide natin, ngayon, kailangan natin i-identify ngayon is ano yung i-require ng formula, decode, para makalculate natin yung block shear strength ng ano natin, member natin, yung connection ng given natin. Okay? So, according to NSCP 2015, Section 510.4.3, ito daw po yung formula para gamitin yung block shear o yung, identify yung block shear rupture dun sa tension member natin, dun sa connection natin. So, as you can see, this formula is very long, ano? So, medyo ang challenge for us is, or medyo intimidating siya tingnan, ano? Kasi it is a formula na may bali 4 na terms, tapos meron siyang conditional sa gitna niya, no? So, to better understand this formula, siguro i-explain ko muna itong conditional natin na do sa equation natin. Once meron tayong symbol na ganyan do sa mismo equation natin, it means na we need to take yung minimum do sa dalawang expression natin. Okay? So, kaya itong formula na to, simplify ko further now to this form. Okay? At least, mas madali siyang intindihin na dapat ang kukunin natin is minimum value between the first set of equation and then versus to the second set ng equation natin. Okay? So, madami tayong mga bagong terms na kailangang i-consider, pero as you can see, yung mga calculate natin is yung nominal capacity pa lang. Ano? Nominal pa lang siya, so meaning hindi pa siya multiplied by a resistance factor or divided by a safety factor. So for LRFD, we need gagamitin natin is 0.75 na fee, katulad nung sa net section rupture. And then for ASD, i-divide natin is 2.0, katulad nung sa net section rupture loss. Okay? And then meron tayong bagong term na UBS. So nakalagay dito, when tension stress is uniform, we set UBS is equals to 1.0, otherwise 0.5. So later, di-discuss natin yan. Pero look at yung simplified version na isa. So if you look at the second term nung parehas sa equation, makikita nyo na parehas lang siya. And then also, mayroong same factor dito sa first term naman natin. So what I did is to simplify this further para mas madali natin ma-memorize yung formula for block shear. Okay? So ngayon, ang gagamitin natin for block shear is ito na. So Rn is equals to UBS, FUANT. So galing yun dito sa previous formula. Ito po yan, ano? Finactor out, nilabas ko na kasi parehas naman siyang gagamitin. And then, yung factor na 0.6, nilabas ko na. So ang kakalculate na lang natin minimum is between FYAGV tsaka FUANT para mas simplified yung consideration natin for the value na kailangan natin is ilagay dun sa equation natin. Okay? So, ngayon is let us consider what are the new terms na kailangan natin maintindihan. So, hindi naman masyadong bago na to kasi we already know what is the meaning of AG tsaka AN. AG is gross area and then AN is net area natin. So, may additional subscript lang siya na V tsaka T. V para sa shear and then T para sa tension. So, let us look at this diagram. Okay? As you can see here, ito yung tension member natin, ito yung applied loading natin, and then as you can see, kapag pinag-uusapan natin is gross shear plane, shear, no? Again, balikan natin yung kanina sinabi natin. Pag shear, ang usapan natin, ang concern natin is an area na parallel dun sa loading natin. And then kapag tension, ang concern nating area is perpendicular. So kung ito yung loading natin, ang possible na mapunit sa atin na area kapag shear ang pinag-uusapan is this portion. Okay? So yung portion niya is from the end bolt natin hanggang doon sa end plate natin. So ang measurement niya is from the center papunta dito sa edge plate natin, edge ng plate. So ito yung kaya nakalagay gross shear plane, yun yung gross shear plane natin, itong position na to. Okay? And then kapag sinabing net shear, ginagawa natin kaya nagiging net is mina-minus natin yung butas na nakikita natin. And ano nga yung formula ginagamit natin? Kapag AN is equals to AG minus yung number ng bolts natin times our effective depth, effective diameter rather, times yung thickness natin. Okay? And then same with gross tension plate, no? Pag tension, again, perpendicular na tayo. Kaya ito na yung consideration natin. Starting from the center, papunta dun sa edge ng plate, perpendicular dun sa loading natin. So that is yung gross tension plane. And then kapag net, ima-minus na natin yung butas natin dito. Net tension plane. And then, yung iba is the same na, no? E sub 1 at E sub 2 are edge distances o yung layo ng mismong bolt natin from the edges, from the upper and right and the corner and the side natin, mga edges. And then we have yung pitch or yung spacing ng mga bolt. And then yung gauges natin na alam na natin na perpendicular din sa loading natin na distances. Okay? So yan yung ilan sa mga bago na mga terms natin. So before we can calculate yung mismong kailangan natin for the analysis, discuss muna natin si UBS. Okay? Or yung tinatawag natin si block shear coefficient, UBS. So UBS accounts for non-uniform stress distribution. So this is actually the same concept with shear lag factor, no? Na kinoconsider natin sa shear lag factor kasi merong uneven distribution of force or merong mga parts ng tension member natin that are under stress. Pero dito, yung UBS, in most cases, equal daw siya sa 1.0. So the only case where this value will be different is when yung block shear natin is on cope beams with multiple rows of bolts. So ito specify natin, ano? Dito lang siya magiging 0.5 o dyan lang iba yung value niya. Pag sinabing cope beam, ang cope beam po ang itsura is yung ganitong mga beam, ano? Yung may chamfer na ganyan. So bakit nagkakameron ng ganyan? So let's say we have a white flange dito, no? Yan, then white flange dito. And then kailangan natin i-connect yung member na yun doon. Okay? So para ma-connect yun, and para maging level yung flanges ng connecting member natin with another flange, kailangan i-chamfer yung top portion ng flange para maipasok siya dun sa web natin and then para ma-connect siya dun sa mismong isang member natin. Okay? And magiging 0.5 lang siya kapag more than one row yung mismong bolt natin dun sa connection natin. Pero kung halimbawa single row lang yung bolt natin, yung connection natin, that will be equal to 1.0 lang. Okay? Again, kapag hindi stated na hindi siya cope beam with multiple rows, 1.0 po ang UBS. Pero pag sinabing cope beam siya with multiple rows, automatic 0.5 yung gagamitin natin. Okay? So for all cases, UBS is equals to 1.0. Alright? So let's now proceed dito, no? So kung doon sa net area natin, ina-identify natin yung critical path natin. For block shear, we need to consider also yung critical block shear path naman natin. Okay? And we can select daw the critical block shear path by satisfying three conditions. Number one, dapat lahat ng bolt natin will be intact together. So dapat lahat sila magkakasama. Okay? So parang katulad sa net section rupture natin, sabi natin before, bawa, ito yung tension member natin, nandito yung connection, tapos nandito yung tension member. Pag nakakonect siyang ganyan, kailangan pa nag-fail siya, dapat may iwan sa isang side lahat ng connection. Tapos yung isa, other side, yung tension member natin. Dapat hindi katulad dito, halimbawa, yung maging failure natin is, halimbawa, ito lang yung natapyas na portion. O ito lang yung naiwan na portion. Ito is nadala. Hindi mo pwede mangyari yan. Ang assumption is, kailangan lahat ng bolt natin magkakasama siya or intact siya. Okay? Same with the saying na dapat yung member natin should separate to sa connection natin. So kailangan matapyas siya totally dun sa connection natin. So, ibig sabihin, itong shaded portion na kulay blue, maiwan doon sa connection, and then yung gray portion niyan, dapat matanggal talaga totally doon sa connection natin. And then, pinakamahalaga is to include a path subjected to shear. Kailangan may shear kasi kung walang shear yan, papasok ulit tayo sa GSY or NSR. Again, dito yung GSR, NSR is dito, pero since meron tayong shear plane, tsaka tension plane, block shear na po ang tawag dyan. Okay? So, ayan. So, yun po yung concept natin for block shear. So, dito sa diagram natin, we have a plate na may grid type connection. So, dito, ito daw yung dalawang possible critical path natin. Okay? My question is, looking at these two diagrams, what do you think yung magbibigay ng mas smaller na resistance or na capacity basing dun sa equation natin? Yung left side na ang matatapyas is itong portion na to, or itong portion na to yung matatapyas o yung may iwan. What do you think yung magbibigay ng smaller na resistance? Kasi ang kailangan natin, di ba, nung nagsaselect tayo ng governing na value ng resistance is yung smallest or smaller value. So dito kailangan din natin ng smaller value. So alin sa tingin niyo magbibigay ng resistance na smaller ang value? Yung left, this one, or yung right one? What do you think, guys? So we need to remember yung formula natin, ano? So we have yung Rn is equals to UBS FU ANT plus 0.6 minimum FY AGV or FU ANV. Okay? So pwede dito kayo mag-base. Okay? When we look at the first equation, the first term, it deals with the tension part. Okay? Ito yung sa tension. So, lagay nga natin. Ito yung sa tension. Tension plane. Plane na capacity. And when we look at the two diagram, ito yung tension plane nung una, then yung pangalawa, tension plane ito. Okay? So, when talking about tension plane lang, okay, the one that will give a smaller value ng resistance is this one. Okay? Kasi mas maiksi yung kanya width compared with this one. Okay? Pero that is just for tension plane. Ang formula natin is with an inclusion of the shear plane. Okay? This is our shear plane. And what can you say about our shear plane? Doon sa first and second. This is the first one. We have shear plane dito sa taas and another shear plane dito sa bottom. Okay? It means twice yung shear plane natin. Sa portion na to, and dito sa kabila, we have only one. Okay? So now, again, I'm going to repeat the question. What do you think will give the lesser value ng resistance? Yung left or yung right? Anyone? Okay? So, the answer is, itong right side, yung magbibigay ng lesser one. Bakit ngayon? Kasi single lang yung sa kanyang shear plane. Ano? As you can see dito, nag-double yung value niya. Although, we need to consider also yung increase na dinadulot nito compared dito. Okay? Pero looking at the diagram, if i-measure mo to versus dun sa dinagdag naman ng length nito, okay? So possible na mas malaki pa din nga yung magiging value nito compared dito. So ang mas smaller ang magiging resistance will be this portion. So ito yung mag-govern na connection natin. Pero to be sure whether which failure path will govern, you need to calculate both of them para maipakita kung alin talaga yung mag-govern sa kanya, and also for you to have a sense of identifying which failure path is critical on a given connection. Kasi hindi naman pare-parehas lagi yung type ng connection included in our design. Okay? So yan. So Iyan yung para sa pag-identify ng failure path. As long as we satisfy yung tatlong condition na to and we can identify yung failure path na required natin, we can calculate the all possible values ng critical path, ng block shear capacity natin. Okay? So, another one is for a certain arrangement ng bolts, yung block shear can also occur dun sa plate kung saan natin kinakasa yung mismong tension member natin. So in this type of connection, block shear could occur in both the gasket plate and the tension member. So let's say, ito yung tension member natin, we connect it into a gasket plate. Ang possible na mangyari is yung una, yung tension member yung matapyasan ng portion. Ibig sabihin, ito yung matatanggal, yung tension member natin yung matatanggal kasi napunit dito no? Or the other scenario is, sasama yung portion ng gasket plate dun sa tension member natin once na nag-fail siya. So, we need to consider both of them when we have this type of connection. Kasi possible na magkaiba sila ng strength. Let's say, dun sa tension member mo, you use a different type of steel. Let's say, an A572 or A992. And then for your gasket plate, you use an A36 na steel. So, strength-wise, one part will be stronger and then the other part will be weaker. So there will be a chance na mangyari itong failure na to sa kanya. Okay? So to better understand the concept of block shear, let's have an example. So let's have this example. So an angle L6 by 4 by 5 eighths, A36 steel is used as a tension member. So a 22 mm diameter bolts are used. Determine the design capacity of the angle according to block shear rupture. Okay? So block shear rupture yung kinukuha natin. So looking at the example, we have a given na A36 na steel. Okay? So for A36, again, yung ating mismong given is Fy is 248 megapascal. And then yung Fe natin is equals to 400 megapascal. Okay? And then we also have a diameter of ball equals to 22 mm. So yung effective diameter of our ball is equals to dB plus 4 mm. So that is 26 mm. Okay? And then we are tasked to find the design capacity based on block shear alone. No? So tingnan muna natin yung size natin. L6 by 4 by 5 eighths. L6 by 4 by 5 eighths is also equivalent to L 150 by 100 by 5 eighths. Kapag kinonvert natin into mm, that will be 15.625. Okay? So it means na on our diagram, this is 150. So this is yung ating 100 dito. Okay? So ito yung 100 natin. And then we have thickness also here. So thickness natin is 15.62. Okay? So, ayan. So ngayon, our task is to identify yung mga possible block shear path natin. So observing our diagram, I hope you can identify 3 possible block shear path. So yung una is the same as the first one, condition natin sa previous slide, na ito yung magiging failure path natin. Okay, that is the first failure path. Another one is the same yung shear plane, pero yung kanyang tension plane is extended hanggang doon sa ilalim. And then yung last one is, ito yung magiging shear plane natin, and then doon naman tayo sa taas pupunta. Okay? So this is our first shear, failure path, second failure path, and then third failure path. Okay? So each failure path, you need to calculate yung capacity niya and then compare them with each other. And then whichever capacity yield the smaller one, that will be the governing capacity for block shear. Then once na meron ka na for block shear, for this example, block shear lang pinapakuha. Pero in reality, you need to compare it with GSY and NSR. And also for the slenderness limitation, if ever we also have a slenderness limitation required to identify. Okay, so let us first start with the path 1. Okay, so critical path 1. So path 1 natin is we have an angle. Okay? Then we have a connection. And then yung mismong failure natin is itong portion na to. Okay? That is our path 1. Ito yung loading natin. So for path 1, we need to identify yung mga required sa formula natin. Starting off with AGV. AGV is yung gross area natin for our shear plane. Okay? So dito sa path natin, ang shear plane natin again is yung parallel. So ito yung magiging shear plane natin, shear plane, and then ito yung ating magiging tension plane. Okay? So for shear plane, kailangan natin ng area ng gross ng shear plane. So kailangan natin yung width times yung thickness. So yung width natin is how much? So that is itong portion na to. Sorry. Itong portion na to. So that is 40 plus 225. That is 265 mm. So we have 265 mm. And then yung thickness natin na 15.625 mm is equals to, so we have 265, 15.625. So we have 4,140.625 mm squared. Okay, that's our AGV. And then next we have A and B. So for net area, that formula will be AGV minus kung ilang bolt yung dadaanan natin o ma-minus natin dun sa shear plane natin. So number of bolts, DET times T. Okay? So dito, laging from center, papunta dun sa edge plate natin, that is our shear plate. Ibig sabihin, number ng bolts is 1, 2, 3, and then half lang dito sa kabila sa dulo. So that is 3.5. Okay? So calculating that, we have 4,140.625 minus 3.5, DE is 26, then 15.625. Our A and B is equals to 6 times 15.625. That is 2718.75 mm squared. Okay, that is our A and B. Okay, next. Let's calculate yung ating AGT. So for AGT, kailangan natin is yung tension plane natin. So ito yon. So this portion yon. And that portion is equivalent to 65 mm yung kanyang width. So 65 mm times 15.625. So that is 65 times 15.625. We have 1,015.625 mm squared. And then we have AGT. So that will be AGT minus number ng bolts, DET. So ilan yung number ng bolts ngayon? So ito lang yung portion na yon. So we have kalahati dito and then another kalahati dito. So that is 1.0. So it's equals to 1015.625 minus number of volt, that is 1.0, 26 times 15.625. So ilan yung A and T na yan? So minus 1 times 26 times 15.65. We have 609.37 mm squared. Okay? So yan yung A and T natin. Now that we have those values, we can now use our formula. Okay? Our formula is RU equals to UBS FU A and T plus 0.6 minimum between FY AGV and FU A and B. Okay? So substitute natin, we have UBS 1.0 kasi hindi siya stated na cope beam with multiple rows. FU is 400, that is Newton per mm squared. We have A and T. So A and T is this one. So 609.375 mm squared plus 0.6 minimum between yung FY natin is 248 and AGB natin dito is 4140. So 4140.625. So pag pinag-multiply, that is 1,026,875 mm squared that is 400 times yung A and B natin is 2718.75. So 2718.75 times 400, that is 1,087,500 mm squared. Okay? So looking at this term muna, kailangan natin yung minimum. So ang governing sa kanya will be this one. So mas mag-govern to sa minimum natin. Okay? Kaya magiging formula natin dito, cancel yung mm squared. Dito magiging, this should be in Newton pala. Okay. Newton. Okay, so matitira is Newton. So 400 times 609.375 plus 0.6 times 1,026,875. And then, anong gagawin natin? Since yung shear plane natin dito is dalawa, kailangan nakamultiply ng 2 yung last term natin. So ito dapat nakamultiply ng 2, nakamultiply ng 2. Before natin i-convert, di ba magiging unit nito is Newton, then i-convert natin sa kilonewton. So 1,000 Newton per kilonewton. So mag-cancel out yung Newton. Yung Rn natin, base dyan will be 400 times 609.375 plus 0.6 times 102.6875 times 2 divided by 1,000, that is 1,476 kilonewton. So this is the capacity of our first pad, 1,476 kilonewton. Okay? Again, that is for nominal resistance pa lang nung part 1 natin. Right? So we still have 2 other paths. Okay? So that is part 1 only. Okay. So for the next path, we continue it into another page. So we have path 2. Okay. So yung ating path 2, ang itsura, ito yung ating L connection. Ito yung ating bolts. Then mangyayari ngayon is yung shear plane natin and then diretso sa baba. Ito yung block nating maiiwan. Okay? This is our applied loading. So alin lang magbabago? We have here the same shear plane. Okay? Same lang ang distance ng shear plane. Ang magbabago lang ngayon ay yung tension plane natin. Nadagdagan siya ng area dito sa ilalim. Okay? So AGT na agad tayo. The AGB will be the same. So AGT is equals to, so yung length na to, so going back on our previous diagram, that is 65 plus 30, that is 95. Okay, so 95 mm times yung 15.625. That is also in mm. So 95 times 15.625, that is 1484.375 mm squared. Okay, that is our AGT. ANT ngayon will be ilang butas ngayon? Meron tayong 1 hole and then kalahati dun sa taas. So 1.5 naman siya ngayon. So 1484.375 minus yung 1.5 times 26 times 15.625. So yung ANT will be 1.5, 26, 15.625. That is 875 mm squared. Okay. Then now we can use other formula for Rn. Is equals to UBS, so 1.0, FU is 400, then ANT is 875 plus 0.6. Tapos yung minimum, the same lang din naman, will be yung 1,026,875. Okay? And then ngayon, 1 na lang siya, times 1 na lang. Eh, hindi na times 2. Kasi we only have 1 shear plane lang. Ito lang yung shear plane. Okay? So, ito yung shear plane, ito yung tension plane. Okay? So, double check ko lang, 126.87. Okay, so that is the same. And then since this is in Newton, i-divide natin by 1,000 again to have our capacity of Rn is equals to 400, 875 plus 0.6, 1,026,875 divided by 1,000, that is 966.135 kilonewtons. Okay, so this is the capacity for our path 2. Okay, so that is for path 2. Okay, next. So we have yung path 3 natin. So, asya ba siya dito? Okay, sige, tuloy natin. Ito, path 3. Number 3. So, kay path number 3, we have a angle. Okay. So, 1, 2, 3, 4. 1, 2, 3, 4. And then, ang path natin is pababa. Tapos, aakyat tayo doon. Okay? Yan yung ating black shear path para kay path number 3. Pero the problem is, yung failure natin is magko-cross dun sa other part ng connection natin. And sabi natin, yung ginagawa natin before, pag nagko-cross siya ng other part for sections na hindi siya plate, is we try to convert yung section na yun to an equivalent plate. Okay? So mula dun sa angle natin, di ba naka-angle siyang ganito? Okay? So meron siya dito 150. This is 100. And then this is 15.625. So, tatapyasin natin dito and then talagay natin sa taas. So, magiging siyang, ito yung 150. And then this will be the reduced part. So, ito yung 150. So, yung height nito will be 100. Yung minus yung thickness, which is 100 minus 15.625. That is equivalent to 84. Lagay ko na lang yung diretsong value. No? So 100 minus thickness, that is 84.375. Okay? So when we try to project that to our diagram, okay, ito yung ating line, and then ito yung original na bolts natin, and then ito yung will be our failure path. Okay? So, dito, mapapansin nyo yung shear plane is still the same, hindi nagbago yung shear plane. Yung tension plane lang yung nagbago natin. Okay? Itong tension, itong vertical natin. Okay? Ito yung ating applied loading. Okay? So, paano natin ngayon makakalculate ito? So, we have yung AGT natin will be yung AG ng mismong section natin, and ang AG na section natin for angle. So look at table 1-7, and I think yung para sa L6/4, let me check, L6/4 by 5/8, that is, area niya is 5.86. Okay? So 5.86 inches squared, convert natin sa 25 mm per inch squared. Ma-minus tayo ng portion na to. Okay? So that is, itong portion na to is 30. Okay, minus that is, ayan, 30 tong distance na to, no? That is 30 minus yung thickness natin. Okay? So 30 minus yung thickness na 15 mm, 15.625 mm. Ito yung AGT natin dito. So 5.86, 25 squared minus 30 times 15.625. That is 3193.75 mm squared. And then yung ANT natin will be equal sa AGT na 3193.75 mm squared minus yung half dito and then whole dito, so 1.5. 1.5 diameter ng bolt o yung effective diameter times yung 15.625. So A and T is equals to 1.5 times 26, that's 15.625. So 2584.375. Okay? So yan yung value natin. So kunin natin yung Rn niya. Rn equals to UBS is 1.0. Okay? Times FU is 400. ANT is 2584.375 plus 0.6 tapos yung nakuha ang minimum natin kanina 1,26,875 and then this is all in Newton, so divide natin by 1,000 para maging kilonewton. Okay, so 400 times yung answer natin kanina plus 0.6, 1,26,875 divide 1,000, we have 1,649.875 kilonewton. So, ito yung capacity natin, nominal resistance, pagdating doon sa path 3 natin. And comparing path 1, path 2, and path 3, we have for path 1, that is 1,400. Path 2 is 966. And path 3 is 1,649. Ang governing natin na Rn is therefore the smallest of them three. So that is 966.125 kilonewton. Okay? So pinapakuha yung design strength, it should be PRN para sa LRFT. Okay? So that is 0.9 of that value, 125 kilonewton. So PRN natin is equals to 966.125 times 0.9. That is 869.5125 kilonewton. Then for ASD, gagawin lang natin is Rn divide omega. So that is 966.125 kilonewton divided by, kapag omega, mali, double check. So this should be 75, ano? Times 0.75. Okay? So 966.125 times 0.7. Kasi parehas tayo ng net section rupture, 0.595 kilonewton. Okay? So dito will be 2.0. So 966.125 divided 2, that is 483.0625 kilonewton. So that is the value for LRFD. It is the value for ASD. Okay? So, ayan yung capacity niya kapag gross, pag black shear rupture lang yung pinag-uusapan natin. Okay? Now, let's try to look at the condition if we will try to calculate also yung kanyang cross section yielding tsaka net section rupture para makita natin kung alin talaga yung mag-open din sa connection natin. Okay? So, try natin ilagay dito. So, let's say, yung cross section yielding yung calculate natin. So, let's try yung LRFD lang natin. So, PRN is equals to 0.9 FY times AG. So, we have 0.9 times yung 248, tapos ang AG natin is 5.68 times 25 squared. And then divide natin by 1,000. So, yung PRN natin is equals to 0.9 times 248 times 5.68 times 25 squared. Divide 1,000. So, we have 792.36 kilonewton. This is for GSY ng LRFD. Okay? And then, let's look at the NSR in that section rupture for LRFT. So that is VRN is equals to 0.75 ng FU. Ang AE natin is U times AN. So, AN muna yung pupunin natin. So, ang AN will be AG, yung 5.68 natin, times 25 squared, minus, ilan ba yung mga na-rupture natin dito? So, dalawang bolt. So, minus 2.0, 26 times 15.625. So, ang AN natin is 5.68, 25 squared, minus 2 times 26 times 15.625. That is equals to 25 squared, 0.026, 15.625. Wait lang. So, 5.68 or 86? Kaya mali pala ang aking nilalagayan. It should be 86. Okay. So, this is 86. This is 86. Okay. So, 5.86 dito. So, 0.9248. 5.86 times 25 squared divided by 1,000. Yeah. So, this should be 817.47. And dito, 5.86 times 25 squared minus 2 times 26 times 15.625. That is 2,850 mm squared. Okay. So, yan yung NSR natin. And then, we have yung shear lag factor natin. Ang applicable cases natin are case 2 tsaka case 8. For case 2, that is 1 minus bar x con over L con. Okay? So, when we look at L con, x con, ang connected part natin, again, abay tsura ng connection natin. Okay? Pag tinignan nyo yung diagram ng table 1-7, ito yung connected part, yung long side. So, ito yung ating centroid. So, kailangan natin yung position, yung distance na to, which is bar x. So, tingnan nyo lang yung value ng bar x dun sa table 1-7. So, hindi ko na i-pull out dito. Double check nyo na lang. For L 6/4 by 5/8, ang bar x height, 1.03. Okay, so that is 1 minus 1.03 times 25 divided by L ko naman natin. So dito, connection to connection lang tayo. So connection to connection, that is 75 each yung spacing niya. So that is 225. Okay, so this is 225. So U2 is equals to 1 minus 1.03 times 25 over 225. That is 0.886. Okay? For case 8, so magsasatisfy tayo dun sa isang condition. Meron tayong 4 fasteners per line. I think Q sub 8 o U8 natin is equals to 0.8. So according to the definition, dapat ang governing natin is whichever is larger sa dalawa. So 0.886 yung magiging value na U natin. Okay? So to get for the value of V, lalagay lang natin lahat ng values natin. So saan ba natin dito? So separate ko lang to. Then lagay ko to dito. Okay. So ang magiging PRN natin, PRN is equals to 0.75. FU natin is 400. U natin is 0.886. And then area natin is 2,850. And then divide natin all side by 1,000. So VRN is equals to 0.75 times 400 times 0.886 times 2,850. Then divide 1,000. We have 757.53 kilonewton. So this is the capacity based sa net section rupture natin. So net section rupture is this one. Gross section yielding is this one. And then, yung atin para sa block shear will be this one. Okay? So comparing the values of these three, what will be the governing value or capacity? So the governing one will be yung ating sa block shear. Okay? So kapag tinanong, say block shear yung magiging design capacity natin for our section. Okay? So ganyan po yung pag-calculate niya kapag pinagsama-sama na po siya lahat. Alright? And that will be the same scenario kapag sa examination natin by next week. Kasi you will be given a tension member and then you need to check the value of the nominal capacity based from the cross-section yielding, Then for net section rupture, if slenderness is given, you will calculate also the slenderness limitation. And then the black shear rupture or black shear strength of the connection natin. Okay? So, ayan po. Question po? Okay? So, ayan po yung sagot dito sa problem na to. So, one note to consider, maybe some of you guys are wondering what if yung connection natin is naka-stagger, ano? So, pag naka-stagger, ganun pa din po. Pwede pong magka-failure siya ng stagger siya. So, dito, gawin natin stagger pa. So, kapag staggered siya, so pwedeng maging ganito yung connection natin. So, yung unang failure natin, failure path, pwedeng maging ganito yung itsura. Okay? Yung sa pagkasunod ng failure path, ganyan, tapos bababa siya. And then, yung pangatlo is yung pataas naman. Okay? So, para makonsider yung length ito, ang gagamitin mong value, syempre, yung staggered factor ng formula natin na S squared T over 4G. Okay? So, we will try to solve this kind of problem next meeting para mas maintindihan nila yung process in calculating for the black shear if the given connection is a staggered type connection. Alright? Sige. So, this ends our lecture for today. Okay? So, I hope ma-review nila later on yung concept related dito sa topic natin or last topic natin for tension member.